Well, here are the OSI layers. There's 7 of them, and I'm going to try to kind of break them down. And we'll start at the bottom. And in fact, we call these bottom 4 the lower layers. So, of the OSI. Layer 1, we're talking about bits. And what do we mean when we say bits? We mean ones and zeros. Now the question is how do we send them? Well, we can send them electronically over a copper cable. We can send them as photons over a fiber optic cable. We can send them as radio waves with radio frequency. We can send them through infrared. We have a lot of ways to communicate ones and zeros, on and off. But that's what we see at the physical layer, is that at some point we need to encode our message that I want to send to you as a bunch of ones and zeros. And it doesn't matter to me the type of medium, that's another word we hear about, that you use, as long as I can convert it to ones and zeros and it will transport it along. Now, we have at the data link layer what we typically called frames. And the frames of data deal a lot with what we call network encapsulation types. So what does it mean to have an encapsulation? Well, what it means is that there are, as I said, different types of forms of communication, and I'm going to stick with Ethernet as our example. So I have a computer over here, we'll call it computer A, and I have computer B. And computer A wants to talk to computer B. And so somehow they are wired together. And there may be other computers that I could talk to, but I need to find a way to address my communications from A to B. And with the world of Ethernet, we use what's called a media access control. Some people call it just the MAC address. But it's a way of basically having a layer 2 hardware address that I can address my communications to be. And whatever this equipment is that's interconnecting us is capable of reading that address and knowing how to send our information. So it is an encapsulation protocol. Ethernet is one example. You're going to see types listed to you like ATM, frame relay, ISDN, X25. You're going to see a lot of different types listed, but you don't have to know them in great detail. The network layer is what we like to call the logical address. In fact, that MAC address in my Ethernet example, that's a permanent address. That's burned into the cards. You can change it, but, you know, not that many reasons to do it. But this is a logical address. And I'm not going to get too far into it at this point, but the example is IP. Right now we use version 4. I already told you IP version 6 is there. Now, I told you we encourage open standards. For the longest time, Nobel had a type of addressing thing called IPX. And it was very good. There's nothing wrong with it. But it was a proprietary solution. And it worked with the transport layer, it worked with the data link layer, so it fit in just fine. But because it was proprietary, nobody else wanted to use it because they had to pay royalties, so it's not around anymore. Okay, so here we've got this network layer address scheme. And we use it to help in the delivery because, you know, not everything is right here in my local area network. Some things are out there in the internet world. Let's make the internet a happy place. And so I need to figure out, right, the devices in between where I am and where I want to go. Maybe over here to a wonderful web server. We need to have a way of getting there, and IP addresses help break down the network, the large network, into smaller pieces so that we can address our package and send it there. It's kind of like the idea of putting a zip code and an address, because an IP is both kind of like a zip code and an address. The zip code tells the post office what city to send it to, and once it gets to that city, then the rest of it tells you the address in that city. And so it's kind of really cool technology if you want to look into it. It's I don't think it's all that complicated until you get into subnetting stuff. We have the transport layer. This is really kind of a language. Now, I forgot to do something here. Back at layer 3, we often call these things packets. So when you hear somebody talking about a packet, they're talking about something that has an IP address on it. If they're talking about a frame, they're talking about something that has the MAC address on it. Now, this is the language of communication. It's a transport protocol. two very common ones that we use frequently is the transmission control protocol and the user datagram protocol, TCP and UDP. And they're just methods of communicating. The idea is that when I send you information, we need to have a common language so that you know how to put things together. TCP is very much, I'm going to draw a little line out here, a segmented type of protocol. In other words, it takes your large piece of information and breaks it down into little pieces that are manageable by the network. And TCP contains the instructions to tell you how to put them back together. So, and it's a very nice protocol that allows us to have acknowledgments. And again, I'm not going to get that deep into it, but just so you get an idea of how this works. The session layer is our communications. You know, what is the thing about a communication? You need to know when I'm ending a communication. You need to know when I'm going to begin a new communication. And you need to isolate my communication so you don't get me confused with somebody else. And so that's what happens at the session layer. And by the way, we're now at layer 5, and we've just gone into the upper layers of this stack. Now the next part we have is the presentation layer. And I like to use the word format. But format can still be a bit ambiguous. Some people use the term file extension. Basically, here's the thing. If you've ever worked with pictures on the, in your network, you know that you have some pictures that are JPEGs, some that are called GIFs. I've heard some people call them GIFs, so I don't know which it is. You have TIFFs. Okay, well, you know what? I can save my picture in any of those formats, and it's my understanding that some are better for higher compression or more, better, I guess, clarity or resolution. I don't know a lot about that part of it. But what I do know is that the program, the picture, has to be encoded in such a way that whatever software package is looking for a JPEG can read that file and know it's a JPEG and know how to draw it. And so that's what I call the formatting, that it's stored in a certain way. You know, in the old days, when we used to want to listen to music, we downloaded what were called WAV files. And a WAV file was about, I want to think, 5 megabyte size file for every 1 minute of music. Today we have MP3s that is, if I gave you a 5 megabit file, I had like a 7-minute song. But it's the same music. But there was something about the way in which that file was put together in combination with the software that would read it that gave us better compression. Perhaps it's not compression. But you get in the picture, right? It's how things are stored as far as the format. And then finally, we have the application layer. And, the best one to use as an example is HTTP, Hypertext Transfer Protocol. You know, that's one we use to be able to send and receive HTML files that we're going to open up in our web browser. But, this is where we get involved as users. We interact with the application, and then it goes on from there. Now, in a typical setup, and I kind of run out of room to do this, but in a typical setup, what you would see is I'm going to download this really large MP3 file from you. And let's go ahead. We'll say it's 5 megabytes. Now, the problem we have is that in Ethernet, the largest packet we can send is 1,500 bytes. So that means I have to divide this thing into a lot of little pieces and send it to you one little piece at a time. So what we do is we take that little bit of data that I'm going to send you, and of course, remember now the session layer is going to make sure I don't get confused. I know what kind of file I'm sending you, an MP3, right? The application is sending it. So what we do is we add onto it this TCP information, and I told you TCP's job is to help me put it back together. You're sending it to me in little pieces, and TCP is going to, through a series of sequence numbers, is going to help me know the order that I've received it and how to put it back together. But I need to know where to send it, so I'm going to put your address. Now, I told you that an IP really would be kind of a good example of a zip code, right? That's going to get me to the city. But once I get to the city, I need to know exactly what your address is, and that's where we have the MAC address of layer 2. And let me erase the word zip here. So really what we're seeing here is layer 4 of the OSI, layer 3 of the OSI, and layer 2 of the OSI. Now, once we got to layer 2, we're done. We don't, right? Well, you're saying, no, Ken, there's another layer. No, not yet. We're done. We've got all the information we know about how to deliver it, how we're speaking, how we're communicating, how you're going to reassemble it. We have the data. We often put a little checksum at the end here. Some people call it a CRC. Others might call it a frame check sequence. Either way, we've got this checksum so we know that if it gets interfered with on its way, that you can tell that's bad. But now what do we got to do? We got to turn this file into a bunch of ones and zeros so we can send it to you, and that's where we get to this layer 1. So this process that I just described to send the data is called encapsulation. And once you receive it, you will de-encapsulate it and take it all apart.